Welcome to the Titus Timeout podcast. I am Matthew McLaurin. In this podcast, we will discuss the control sequence used for series fan powered boxes with sensible cooling coils. These are commonly referred to DOAS boxes. Our model is the DLSC. In order to understand how the control sequence for the DLSC differs from a traditional series box, like our TFS or TFSF, we'll start by looking at the standard control sequence for these boxes. With airflow on the vertical axis and room temperature on the horizontal axis, we can start by identifying the heating set point and cooling set point. Between the two, you'll have the dead band where both your fan and primary airflow will be at their minimum settings. As room temperature increases beyond the cooling set point, the primary air valve will open to increase the volume of cool air supplied to the space. At the same time, fan speed will be increased to maximum flow conditions where primary air and terminal discharge airflows are equal. In a similar fashion for heating, as space temperature drops below the heating set point, fan speed is increased to the maximum heating set point, utilizing the induced airflow from the plenum as a first stage of heat. Once maximum heating airflow is reached and room temperature is still below the set point, the heating element is activated. This could be either electric heat or hot water heat. In heating mode, primary airflow will remain at its minimum level. With this as a baseline, we compare it with the control sequence for the DLSC. Heating operation for a DOAS box is the same as on the standard series box, where airflow is increased to its maximum heating flow, and then the heating element is activated. In this case, it could be an electric heater, hot water coil located on the discharge unit, or it could be through the sensible coil on the induction port. For cooling operation, as room temperature increases beyond the set point, the first action will be to open the chill water supply valve. If the room temperature continues to increase with the valve at full open, fan speed is increased, resulting in higher induction airflow, maximizing your cooling capacity. What we are missing at this point is primary airflow. With a DOAS box, you have decoupled the sensible load from the ventilation and latent load, enabling you to minimize the size and energy consumed by the primary system. There will be two values that will determine the minimum primary flow rate: the ventilation requirements and the latent load. The system should supply whichever is higher at that given point in time. Don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.